This is Thomas Van Bommel with MOBI3002, Assignment 3, 2D balls. For this assignment, we started it with a project, Android project that had a bunch, when you swiped, it would create balls, and those balls would bounce off the walls. When there was created 20 balls, they would reset, and you just do that. So these challenges: change the box color, i.e. the background color. What did you do? Hopefully I do remember to hide the assignment when I'm going through the code this time. Let's see here. So for the background color, if we go to the bouncing ball view, it was originally up here as the bouncing ball view's box, which is drawn to the canvas. And so I just added an integer up here to hold the color of canvas color, which calls my function random color from my functions class, which I'll show you in a second. And then you can see that the canvas is just covered in that color. And if we come down here on the on touch event, whenever there's not an action move, we get a canvas color change. So this function.randomColor, if we go to my functions class, I was going to originally use the colors.valueOf from Android, but I chose an API version that was too old, and so I looked up how they do it in their colors class, and they just use this bit shifting, which is a lot simpler than it looks. Basically 32 bits, alpha, red, green, and blue. So, I mean, it doesn't get much easier than that. And then the random color up here just sets random RGB values with a solid alpha value, so it's not transparent at all. And so that's how I get my random colors. And so if we play that, you can see that we start off with this random color. And if we do anything other than a action move event, we get a color change. So I'm just clicking right now. Change the color of newly made balls to a random color for each new ball. In the here we are. Number 2 here. Sorry, I didn't show you that. So in the ball class, I created 2 new constructors. Each of them call my random color function. One of them has no parameters, one of them has an XY velocity XY. So let me go to the bouncing ball view. You can see that I've replaced the constructor with my own. And this now, instead of making it whatever color it was, makes it at the random color. And so if we play that, we can see that you get random colored balls there. Alrighty. Make the newly made balls go super fast and super slow with a code change. So to make the balls go super fast, we could simply go into the collision detection, and every time they say bounce off the right hand side, we will just make their speed multiply equals minus 10. I don't know if that will do what I want it to. Yeah, there we go. super fast. You can't even... oh, it's not even showing up on the display. They are bouncing back and forth, but it doesn't look like it on there. I'm recording from a second computer. That's why you're not able to see that. So we'll stop that. Return that back to the way it was. And I mean, to make them go super slow. Just simply modifying the speed on them. And yeah, they're pretty slow. It's, yeah, hardly updating. No, it's smooth though. Looks nice. So we stop that. Get rid of this so it doesn't bother us later. Try different approaches to the invalidate method. When I saw how invalidated worked, I wanted to make like a frame limiter. And so up at the top here, I've got a target FPS and the last frame, which is nanotime, which is a billionth of a second, I think. And we go down to our on draw, which is basically our loop at this point. We're calculating now, which is now, delta, which is the time from last frame to this frame, our target milliseconds, which is 1 second divided by our target FPS. And then we take our target millisecond minus that delta, which would be our sleep time, and then set our last frame to now. And then if our sleep time is greater than 0, then we try to sleep. So if our target milliseconds, from like our target FPS is say 16 milliseconds, and our actual delta was 18, it would try to sleep for those 2 milliseconds, which I mean in theory sounds great, but the computer's not that accurate to sleep for that amount of time, so it does not work in practice very well. At least not the way I've implemented it. So if we go up here, we can set these frames. So if we set that, say 15 frames a second. I'm not sure if you can see it, but I did make a little debug menu that shows you the frames per second up here calculated. Down in the on draw method. Right here, it just takes 1000 divided by delta. And you can see that we're hitting about 14 to 16 frames. And if we scroll back up, go 45 frames. And it looks like it says 62. So yeah, I'm not sure how well it works, but it was something I played around with. Did the program work every time I moved the invalidate? Yes, I was playing around with just moving it around. It'll work if you invalidate the frame, but like it'll just draw less. And then if you remove it altogether, it would only call the function the one time. Now, I'm not quite sure how you can do it. You can see, like, down here in the log cat, that it is still adding items. You know, stuff's still working. It's just not drawing. What does invalidate do? Tells the render engine to draw that frame, or redraw the objects. Or I guess it would tell it to show the buffer and then redraw the buffer. What are the times that onDraw is called? Whenever you call it would be a good time. Also, every frame that the phone would want to render is when onDraw would be called. Add another shape class. Fast swipes make the new shape. Slow swipes make circles. So let me just make sure I have this set up correctly. So I made a square. Here's my square class. Simply extends ball. Has a very similar constructor. Calls my constructor in the ball class. And then just draws slightly differently. Draws a square instead of a circle. And fast swipes and slow swipes you can see on my on touch event in the ball or bouncing ball view. If we have a delta x and a delta y, which is calculated from your current x minus your previous x, and your current y minus your previous y, I simply took the absolute value of those to ensure that they're positive. If they're over 30, we're going to draw our square. If they're under 30, we're going to draw our ball, or equal to 30. And so if we play that, and we speed up our balls. Oh, sorry, we're not drawing, or we're not invalidating our frame here. Oh, what have I done here? Oh, I think I was just in the wrong function. There we go. So slow gives us the balls, fast gives us squares, or above 30. If we stop that, oh, I guess we don't need to really. Add a rectangle shape. Anytime a shape collides with the rectangle, you increment the score count. Show on the log cat. So here's my rectangle. Very similar to a square, except it's x is 1.2 times its radius, and its y is 8.8 times its radius. Made this collision method, which is an override in the ball class. When it collides, I simply add a collision call to itself, this collision function down here, which had a log. I commented it out. And so I'm just overriding that collision method. Every time it collides, it accumulates points up here in this static points variable. And then there's a static method down here to grab those points. And so if we replace, say, our circles with squares, or rectangles, replay, draw slowly, we can get our rectangles, and we can see in the logcat that it's printing out our score as we get collision points. And I also added it up to this little debug menu in the top here as well. Think of another change and add it yourself. What did you do? A couple of things that I really liked was, or a couple of extra things I did. I did the debug menu. Oh, 1 second here. I did the debug menu, which was an extra. I did the frame limiter, which was an extra, and I did the color functions, which was an extra, and I didn't need to do it, but I did it. And probably one of my favorite is the color functions. I like how it works, and it was kind of fun to learn. Yeah, it definitely looks a lot more challenging than it is. So if we just go back to the assignment. And so that's the assignment. So this has been Thomas Van Bommel with MOBI3002. Thanks for watching.